Welcome and thanks for joining. We are going to start shortly. Yeah, good evening, everyone, and thanks for joining. Just give us a few minutes. We are going to start very soon. Our speaker is here already. Yeah, just a few minutes. Thank you. Yeah, good day, everyone, and trust we have been doing good. Thanks for joining the call. So, as we all know, today we are going to be talking about AI/ML. So, we have been getting a lot of requests that we should bring a speaker that is going to talk about AI/ML. As we all know that in this age that we are right now, so we are now in the era of AI, and it's just very the best thing we can just do for ourselves, just to know how to use this AI, how we can get started, and different things about AI and machine learning. So, and now here we have our speaker here. His name is Salim Onyula. He is also a GitHub Campus expert and is a machine learning engineer, and he has a lot of experience in that field. So he's going to be the one to enlighten us on this topic that we have today. So how to get started in AI ML as a beginner. So we are going to be having lots. If you have any questions, we can just prepare them towards the end of the call. It's going to answer all our questions. So we're also going to have some um practical aspects that is going to show us some coding aspects, how we can get started and everything. So yeah, so the floor is now yours, Mr. Salim. So you can get started now. Yeah, thank you.
Um, Good evening, everyone. Thank you very much for the warm welcome, Abdulrahim. Thanks so much for having me. Just give me a second while I pull up my slides. Just give me a second, please. Uh, okay. So my slide, just a little disclaimer ahead of time, right? One, I tend to speak really fast, so please, if somewhere down the line you struggle with hearing me, please be sure to let me know. Just throw it back. Especially when I'm excited about what I'm saying, I tend to speak really really fast. So just throw me back, please. Secondly, my slides are a bit here and there. It's not my best work. However, I reckon that we should be able to make sense of it. I'm so sorry. Just give me a second, please. I'm trying to pull up the exact slides I need. Okay, yeah. So just give me a second. I will share my screen from two. Okay. Um. Okay. Turns out I'm not allowed to share my screen. I'm doing my eBay.
Yeah, I'm here. You should be able to share your screen.
It says I'm not
Okay,
sharing.
can you please try again now?
Oh yeah, it works now. It works now.
All right.
Okay. Um. Let's go over here. Slideshow. Let's start from the current slide. Okay. So yeah. Hi everyone once again. Thanks so much for having me. Today I'll be speaking on getting started with ML and AI. As Abraham rightly said, we live in a world where everyone is talking about AI this, AI that, um, large language models here and there, ChatGPT, YanGPT, MCPs, RAG. That's what we're all talking about right now, right? Since I think um AI became more mainstream since the release of ChatGPT in November 2020. Is that 2022 or 2023 now? It's like 2023, I think. It should be 2023. Was it 2022? But yeah, since the release of ChatGPT, since ChatGPT became public that November, the way we see AI has become very different. AI has stopped being that thing we think of in the context of sci-fi movies, or perhaps in the context of research papers, and I think we've moved closer to AGI. AGI meaning artificial general intelligence, in the sense that AI is more available to anyone. Everyone with a phone and internet can now use an LLM. You don't need much. You could not. Matter of fact, ChatGPT is even so good that you don't even need to create an account for you to be able to use an LLM now. So it's really mainstream than it used to be. Um, so a little introduction about myself. Like I said earlier, I'm Salim Moinullah. I go by Salim Moinullah on every social media platform: Instagram, LinkedIn, Twitter, everywhere. Salim Moinullah. And I'm a Gold Microsoft Lens Student Ambassador. I'm also a GitHub Campus expert, right? I build AI solutions and I write technical articles and everything between AI, ML, and cloud computing. In terms of cloud computing, I'm particularly interested in Microsoft Azure. I love the concept of storytelling. Yeah, I feel like if I told you a story, you don't remember. Like everyone on the call remember. But if I came here and I talk about the random facts, chances are that by the end of the day, you probably would have forgotten. But then stories stick. and I love that about stories. Finally, I love good sitcoms. Sitcoms, so Big Bang Theory, The Office, Brooklyn Nine-Nine. You find me there, yeah. So if you have good sitcom recommendations, please, please, by all means, recommend them to me. See, I'll love for your recommendations. And about the recommendations, though, if you think The Office is not good, please don't recommend anything to me. I won't be trusting your recommendation. All right. So what would I categorize as my target audience for today's session? Mainly beginners with little to no experience in AI. So as a matter of fact, I don't even need you to like as a beginner, little to no experience, exactly like Egbowa. That's what I want to work with today. And the learning objective today is to enable the attendees to understand the basics of artificial intelligence and machine learning. Um yeah. So we'll start with a little introduction, right? We'll talk about the divisions of ML, supervised learning, unsupervised learning, large language models. Thereafter, we'll talk about that. I think I'm really keen on sharing as much learning resources as I can. So I'll make sure I send a couple of links. I have a couple of um, links in mind because I think that would be a good ROI, a good takeaway from this session. If you attend a session, be able to have. I mean, although this session should give you a good introduction, there's only so much we can do in an hour. So it would be great for us to be able to go back and take a look at this learning resource and move forward with that. Afterwards, I'll have a quick ML app, probably at the 35 45 minutes mark. I'll start doing this regardless where we're at, and then we work together. Hopefully, we have no bugs, but no, it should be a simple ML app, and then we just see where we are. Okay. Um. Yeah. So before we get all started, let me just speak about my story in general. My ML journey, how it has been. Just to, I think it might be a lesson or two from my story. So I started. I was my first line of code in 2020. Code in general, just 2020. I wrote Print Hello World as we all do in Python, and I think when I think about my tech journey, I think about the start as very unconventional, in the fact that although many people just get to learn before you get an internship, I got an internship before I started learning. So at the point where I got this research machine learning internship at a biotech company, the only thing I knew how to do was to write. If you code here, I could print hello world in Python. I could write for loops. But that with that, I wasn't very confident. But I mean, I could make sense of a for loop and a while loop, and that was it. That was like new. Thereafter, I was lucky enough to get an internship at what's the name again now? Trep Labs. Yeah, Trep Labs. It's a biotech company owned by two graduates of Federal University of Technology, Akure. They had this, they were this acceleration program from MIT at the point, accelerator program rather. So I got into there. Then it was literally on the call with the CTO, and the man asked me, "What do you do in tech?" And I'm like, I don't know, like, and everyone there was like, it was seven on the call, but it was seven interns in general, and the many guys they're saying back end, full stack. I'm like, what's this year are saying? And I remember just looking up what tech skill is most related to my course of study. So I studied electrical and electronics engineering here at the University of Lagos. And I'm like, okay, you know what? Machine learning pops up. Like, I just told my machine learning, but then I didn't know anything about it, but it's something I would like to be well versed in, and that's what started my journey, right? So I picked machine learning. The company they were nice enough to pay for my first course was this Andrew Ung. I'll share the link to the course at the end of the session. Andrew is a Stanford adjunct professor. So within I got started with that. And machine learning is I think it's something very, very important also to learn about machine learning. The entry barrier is very high. So as opposed to, this is a good way I think about it. If you have two simulations of Salim, you have one Salim that is doing software engineering, pure full stack, pure backend, pure frontend, whatever, just software engineering, right? And then you have another Salim that is doing machine learning. They both started on the same day. They both got a laptop, both started coding the same day. They both have the same motivation. They both like the same everything, same environment, same access to resource, same everything. What will happen is ultimately the software Salim would have I don't use the breakthrough. Let's just say the start of your career for the software guy would be much that be softer landing than the ML guy. So ML is a very you'd find I think now it's easy enough now. Those things are becoming more generally public. But as of 2021, 2022, you find applications to ML roles. I thought you need to be for an internship, you need to have a PhD, you need to have a master's, you need to have written X and Y research papers, to have submitted research papers to X and Y venues. It was really research centric, and the barrier for entry then was really high. You feel me? I think it's still high now, but like it's better than it was back in the day. So that really affected my journey. When I think about my 2021, 2022 ish. Yeah. I had a couple of freelance projects somewhere in the process, works for a company that I love writing articles. So then I started writing for, I wrote for Digital Ocean, I wrote for Paper Space. Well, I'll just have whatever it is I'm excited about in the machine learning space, I'll just write about it and I'll get paid. And that was really nice for me because not only like, I mean, getting paid is always nice. And more importantly, it also helps me with learning about the space, because now you know what's happening. I mean, if I'm going to write about what's happening in the space, I probably have to be abreast with everything in the entire space. So thereafter, and it wasn't always a linear journey, but now I currently work with a YC Box company as an AI and ML engineer. So that's a bit calm now. But the big lesson is just how the space is, and it's extremely fast paced. Just to buttress my point about how fast paced it is, 2024, I spent about 6 months away from AI. So I had to do this whole Cyrus thing. So I spent 6 months in the energy industry away from AI. I mean, I was working on this particularly stressful ML projects, but then I wasn't learning anything new. I was only using past knowledge. And after those 6 months, I came out of those 6 months, I felt extremely left behind. That's how fast the industry is. Like 6 months ago, nobody was talking about MCPs. Now everyone's talking about MCPs. MCP being model. It's a protocol. I've forgotten the C. MC model something protocol. But the idea is just to make sure everything is. It's like a USB C. You can think of the way USB Type C is for phones. How for gadgets actually, how we can use Type C for your laptop, for your phone. That's what MCP is about. So it wasn't a concept that was mainstream 6 months ago. Right now, it's something everyone wants to talk about. Same with, I think, likewise, a year ago, people were not talking about RAGs. That's retrieval augmented retrieval augmentation generation. But then today, it's a bit, everyone wants to talk about RAGs. RAGs is basically you giving context to your large language models. So that's also something to just note. It's extremely fast paced. That being said, you know what? Or ML. So again, just to reiterate the things we go through, what ML and AI really means, the tools, resources to get started, career opportunities in the field, and how to start building simple projects. So let's just come all the way here. As you can see, the slides are borrowed actually, but then it's to do the job. Okay, just give me a second. Can you see this work? Okay, awesome. So now, what is machine learning here? So I think the first thing we should think about is how do we learn as humans? Like, think about it. Like, how do we learn as humans? Please, let's unmute. Let's make it a bit more interactive. How do you think we learn as humans? You can also send a text to the group chat, to the chat box. How do we think we learn as humans? Why you guys living? I mean, how do you think we learn as humans? Just random. What do you think? How do we think? There's no really. And another thing is, there's really no one fits all answer. Just tell me what you think. Probably right, anyways. So, how do you think we learn as humans? Yeah, go on, Precious. And thank you very much for raising your hand.
We learn from examples.
Awesome. That's exactly
Tasks.
what I want to hear. Exactly. So as humans, we learn from examples, we learn by experience. So I think my favorite analogy is we all know what the lantern looks like now. The lantern from Lantern, verbal reasoning and quantitative reasoning books. The lantern, right? And let's say there's a big house, right? And then the house is being lit up by the lantern. And the lantern is placed in a specific place in the house. On the other hand, you have an infant, say a 17-month-old baby in the house, right? Probably calling. It's 17 months, probably walks already. So let's work with like 9 months, okay? Calling around the house. And then the kid, let's call the kid Salim. Yeah. So Salim, there's this 9 months old Salim. He sees that thing and then touches the lantern, he cries. When he cries, they're begging him, However, the next time he sees a lantern, the child knows not to touch it. Right? Now, does a child what you have to ask yourself is, as an adult, I myself I know that's a lantern. But then a 9-month-old child doesn't know that thing is called a lantern. What the 9-month-old child knows instead is, okay, that's a silver thing. Probably registers that this thing is placed in X and Y part of the house. Probably registers that it has a transparent, it's transparent in the middle. However, there's a glue that comes out of it. Probably registers, it probably registers that has an handle that can be, like I used to hold it at the top of it. Like, so ultimately, the child registers features of the lantern, not the lantern in itself. And then just registers that, okay, this is bad. This doesn't come with a good feeling. In a similar sense, let's say you give a child a cake. Child doesn't know this thing is called a cake. Just knows that, okay, this thing that looks essential, maybe perhaps a cupcake probably lends the packaging of the cupcake, or it lends that, okay, this thing that looks this way, or this thing that this particular person gives them might be their dad, their father, like, whatever it is, right? So that little analogy there is also how computers learn. So computers, the textbook definition of machine learning is training a computer to think the way a human does without explicitly programming it. The without explicitly is just telling that. You're not telling that that's a cake or that's a lantern. It learns from the features, so it's not explicitly programmed, right? And we see here this is how traditional programming works. So it goes, the way traditional programming works is you give it data, you give it a program, say do X and Y, and give it an output. This is literally the definition of a computer from what we did in secondary school. A computer is a electronic device that takes in data, processes it, and gives an output. But then with machine learning, what you're giving it instead, you're giving it data, you're giving it output, and it gives you a program. Let me explain. Another good analogy is, we've done the infants example. Let's make it a bit. Let's work with perhaps HSS2 students, right? HSS2 students. I don't know about you guys, but I wasn't a big fan of my math teacher in HSS2. So your math teacher comes into the class, and he comes in and he says, "Hi guys, we're working with quadratic equations today. What's this man on about?" Then he comes in, he probably gives you x squared, gives you 2 quadratic equations. Then he tells you, the whole sum of looking for the common factor. What 2 numbers would you add together to give you this, but multiply to give you that? Comes with that example, gives you maybe like 3 of those. The way they do now. Afterwards, gives you a classwork. Right. So now, in that little instance here, what we are doing is you're learning from example. So he has given you it's a little machine learning model in that sense that the 3 examples, that's data. Has given you a data set of 3 rows, so to speak, right? And it's giving you the answer. It's not telling that, okay, so you've seen how this one is done. Now do this one that you don't know the answer. That's exactly how it works. Like, I think I can't think of a better analogy than that. So you give it, and I love the analogy so much that you would agree with me that if I gave you 1 example, you probably would not understand it. But then if you give you 10 examples, now you understand more. In a similar sense, most often than not, in the machine learning context, more data means better model. Because you've seen more. The same way our parents probably know more about life and us because they've seen more. They have more experiences. They have more examples, so to speak, right? So that's also how machine learning works. Now, okay, let's work with this. So obviously, we all know that we can use, although I've given you, like, I've talked about it from a very small level, machine learning goes all the way to help you with handwritten recognition, facial recognition, medical images, and I love that baseline analogy so much that with every single, what I'll do now is with every single example here, these are pretty advanced machine learning context, I would be able to pick it all the way back to learning from examples. Now, if you wanted to train a machine learning model that's able to recognize facial identities, what I'll do is simple. I'll just get it a data set that in that data set you have 1 column that will show this person, that will show X and Y face, and I'll tell you, okay, this person, let's say I'm trying to build a model that recognizes if somebody is smiling or angry, someone is happy or sad, rather. What I'll do is I'll get data sets of face and answer. This person I'll probably get faces of myself in different emotions. When you see this face, this person is angry. This sad. this angry, this happy, this. Like that's what I'll give it. And thereafter, after you've not seen that too, yeah, baby boy. Now that this new face I've not seen before, what would you say about this? That's exactly what you do. Same thing with handwritten or spoken words. If I want to train a model to be able to recognize handwritten handwritten words, I'll probably get a data set that has, I think there's a MINST data set, MNIST. It's a grayscale, it's black and white basically, right? And what it does is you have numbers. I think this should be it actually. So let's say I have a data set like this. I'll say, okay, this one, oh, where my cursor is on, this 0, 0, 0. I'll label it 1, 1, 1, 1, 1, 2. I'll give all the way everything here. Afterwards, I'll be like, okay, oh, baby boy, now that I've done all that, tell me what you think this new one is. That's it. Medical images as well. Let's say I'm trying to train a model such that you could go through your MRI and predict if you have X and Y disease. Could be. I'm not very medically educated, but let's say if you have if you're good, let's say a simple medical checkup, right? You done MRI, an MRI scan, and perhaps whatever it is, you get some MRI. Let's use. I think it's a better one actually. You have an X-ray of your left leg to see if there's a fracture by your knee. I'll just get plenty X-rays of left knees, of left legs actually. Then just go through. This person is working. This person has a fracture. Fractured, not fractured. Fractured, not fractured. And so yeah, generates new ones now. Generating images or motion sequence as well. Generating images. What I'll probably do is this is I love this, okay, because use more generative AI, more LLMs. But generative images, off from my head, what I'll probably want to do is I'll probably want to be able to now, initially what we have is images and they text it. Now you have images and they describe an image. So I'll probably give it plenty images describing what these images are. Probably have an image of me with my parents on my first birthday. I'll write, the way these alt text, ALT text are, like can have on your Twitter images, for instance. You have those really, really, really comprehensive after, yeah. And thereafter I tell you, my guy, now tell me what you think. Like now, generate X and Y pictures because you've learned so much. Now, admittedly, by nature of how generative AI works, the model I just described now will have to be fed with so much data. And I'll talk more about that when I talk about LLMs. The L in LLM stands for large language model. The first L is quite literal. It's a large language model. Thereafter, recognizing anomalies. And this takes me to the second type of machine learning models, that's supervised and unsupervised learning. But I'll piggyback to that. I'll piggyback anomalies. Finally, predictions. So future stock prediction or currency exchange rates. It's really nice to predict the exchange rates in Nigeria, to be honest, with how unstable it is. But then ultimately, what you're doing with prediction is you're able to use past data to predict for the future. Right. So I have a good example here actually. When we work on the demo session, you see that. Yeah. So let's just keep it in mind that I skipped anomalies and I talked about, in the sense that I'll talk about in later on in the context of unsupervised learning. And with predictions, I said I'll talk about it more in the context of showing what's the word now? Of showing a good demo so we can see it together. We'll actually write code later on. We have simple applications here. And just give me a second here. Autonomous cars. I'm edited somewhere. Yeah, this is a good one. Yeah, this is what we are. Yeah. So let's talk about types. Although it says types of learning, think about as type of machine learning because I'm not the one learning, it's a machine that is learning here. So think about just types of machine learning, right? And the first one is supervised learning. Everything I've explained thus far is supervised learning. So you have your data sets, right? And in that data set, it has the desired outputs. Using let me just think of random instances I gave earlier on. The child knowing that this lantern that I showed you here, this thing is bad. He knows the desired outputs. He knows where it's going to. Similar to when your master comes to class and teaches you quadratic equations, you know, like from the examples, just focusing only on the examples he gives in class, you know your desired outputs. Right. Oh, just random. Are you guys following me? I feel like I've gone really fast. Come by show of hands, can we just signify if you're with me still? Awesome. Okay. Precious. I would imagine that's a yes. Sumaya, that's a yes. All right. Thank you very much. Awesome. So basically, every example I've given thus far is in the context of knowing the desired outputs. However, there's another side to that where sometimes you don't know the desired outputs. Now, random. How do we think? And I'm also giving you the example I'm giving to give you is a very pseudo example. It's a very or the answer to the question is quite pseudo in the sense that it's not. Let's work with this right. How do we think? So now let's say I have a new YouTube account or I have a new Google account more accurately, and then I don't like anime, for instance. I don't know how you guys feel about anime. Personally, I'm not a fan. But then my best friend, he loves anime. Okay. So let's say we're out together and he's a bit bored. He opens my PC, opens my YouTube, looks up. I don't know what do animes. I think there's AOT a lot. So that was Attack on Titans, rather. He opens up my YouTube and he watches 1, 2, 3 videos of Attack of Titans. 2 days later, I'm back on my YouTube. You'd agree with me that I'll probably see a recommendation for me to watch an Attack of Titan video, right? So, what is under the hood there? What's under the hood there is a recommender system, and the recommender system falls under unsupervised learning. Same thing, anomaly detection, but anomaly detection is a bit here and there, okay? But let's stick with recommender systems. So now, what does it learn there? The way the model at the base and like on the hood of that, the way it works is simple. And this is a very pseudo explanation. So it's like it learns what it learns is that it says, okay, this Salim boy or this Salim boy YouTube and Google account has watched this. What it then does is that it looks for other people that have also watched that video. What else are those people watching? Do you get me? So if this person has watched something about Colossal Titan, I hate the fact that I know so much about Attack of Titans because you guys know it was your word. But let's say he has watched something about Colossal Titans. I don't know. They'll probably recommend something else about Colossal because let's say Abdulrahim loves anime, for instance. Yeah, Abdulrahim has watched this video X. He also after watch that video X, he also watch video Y. So what they'll now do is they'll create a clustering algorithm. I think the most basic unsupervised learning algorithm is a clustering algorithm, right? And then they'll cluster us together. That little instance, there's no final, there's no desired label, there's no desired output, there's no label to that. It just clusters similar patterns. So it learns more about patterns than about output. Another good instance is the band A, band B, band C thing that they do in that they do with electricity, where you have people with band A, and then you realize that guys that are in band A have similar energy patterns or similar load profiles in the way they use electricity. They probably have these are the guys that probably have refrigerators, I say refrigerators, bunch of washing machines. Like you can see that these guys use light electricity in a similar pattern. So when you get the data set of everyone's load usage, the way they use electricity in the 24-hour scale, you then cluster them together. You see that what we're explaining now, there's no output, there's nothing like you don't really the data set you're going to get from that is going to be 24 hours by it's going to be time by load, time by power data sets. I don't know if you get what I'm saying. So you have the 24 hours on one side, and then it should be juxtaposed with the load usage in kilowatt hour, right? So that instance, there's no, let's say you had that, and then at the end of the day, you had 0 or 1 at one column. Maybe you're predicting if a person is using X. No, that would have been supervised learning. But unsupervised learning would be no, you don't know the answer, but they're able to cluster things together. The last example I'll give on unsupervised learning would be, let's say I got data set on magnitude and longitude, on longitude and latitude rather, on longitude and latitude of people. And I'm trying to create a COVID-19 detection model where I'm trying to get people that have been within contact within 6, I think it was 6 feet of each other then. Yeah. So I'll then create wherever you've been, I'll get a long-term latitude of that. I can create simple question algorithms with that. Like there's no output with that. That's also machine learning. Reinforcement learning is what makes where reinforcement learning works is I think the best example of this I can give is with games. So you know how chess players play against AI. Under the hood of that is reinforcement learning because it's a reward system. So what it does is that let's say you have a chessboard arranged like this, at the risk of coming off as Tunde Onakoya, what it does ultimately is it when you're supposed to make a move, it evaluates the move of every piece on the chessboard at that point, and then so it creates all the instances and then looks for the one with the most reward system. I mean the biggest reward. So it works on the reward system. Another definition says reward from sequence of action. So it looks at every action possible and it's like, okay, this is one you have the maximum reward possible. and it does that. So that's how reinforcement learning works. So you have unsupervised learning. Good. We see here what we have here, right? What we have here is a simple, the simplest regression supervised learning model is regression. The idea of regression is you have a function that's able to predict y given x. So you can have it, think about it in the context of the quadratic equation thing I talked about earlier on. When you know your a, b, and c in quadratic equation, you can predict your two values of x, your x1 and x2. So in this context, it is very similar to what we have in physics practical, where you are given x and y, you have your points. So what machine learning model, what the regression model does here is that it creates a line of best fits. That's a green line here. It doesn't have to be linear. But if it's a linear regression model, okay, yeah, then it can be. But then you have there's always a linear regression. It's a regression model, but then it could be a quadratic regression model. It doesn't have to be a linear regression model, right? And then with classification, you're able to, I talked about whether you have fractured or not, right? I think you can also have models that can predict whether you have breast cancer or whether the breast cancer is malignant or benign. This is a very, very common machine learning use case. It's similar to the Titanic example, where one of the most common early examples you can work with in machine learning. And you have it all the way here. Then you have unsupervised learning, and then I talked about it being clustering system. Now I would like to also touch on LLMs ASAP. LLM ASAP. After this, I'll just quickly have the have the coding session. I really think that should okay. Oh my god, just give me a second, please. Awesome. So ChatGPT was trained on over 300. This is a good one. I think another question to ask everyone: do you understand the concept of sentence? When something is sentence, like sentence. Sentence means the ability to experience feelings. So do we think ChatGPT is sentence? Let me just copy what sentence means. This ability to express. Okay, why is this doing like this? But basically, do we think ChatGPT is sentence? Let's make it quite interactive. You can mute your mic. Speak. Anyone at all? Do you think ChatGPT experiences things? Do you think it's go on to my please? Sumaya, go on, please. Okay, no, you don't think so. Awesome. Alright, so back in there's a time where there was this, I think it's like 2023. This engineer in Google was signed because it felt like AI was sentient, and that there was a whole conversation around it on Twitter, everywhere basically. People were talking about it. And the question is, do you think AI is sentient? Do you think AI is sentient? Basically, do you think it can feel things? Right. So there was a whole conversation around that back then, whether it can feel things, whether it can, yada. But here's the thing. When let me just open ChatGPT. Okay. Okay. Let me do that. Okay, let's just do that. Okay, close cyber. Right. Who is the 43rd president of the United States is? Now you see this good. Now it says the 43rd president is George W. Bush. Now one thing we should really know is that there's a big difference between something knowing that the 43rd president is George Bush and knowing that the likely words to precede to come after this sentence is different from knowing that the answer to this is this. I don't know if I'm making sense. So ultimately, under the hood of your ChatGPT is predicting, doesn't know it too. You feel me? Yeah. So I think that's one very, very important thing to learn as well about LLM. I also to touch on that a bit. So let's just, this is the LLM timeline we have. Say from 1990 to 2017. I talked about how LLM used to be very how onto ChatGPT became public, the LLM timeline was very, what's what I used then? Was very research based, very academic in nature. Now it's a bit mainstream, it's a bit general purpose. Thereafter, between 2017 and 2018, we learned about transformers, and then we have GPT-1, Burst, GPT-2, GPT-3, Codex, now GPT-4. And it started with this paper. Why LLMs are transformative, speed, the scale can operate in multiple languages and domain. The intelligence is crazy as well. You have your AI assistants, Alexa, Siri, ChatGPT, Google Assistant. Even if you try a Google search now, we always give you an AI overview, right? It can help you with content creation. Well, I mean, everything here, the things we know about, right? So how does LLM works? So what it does is next word prediction. That's what it does. That's the most important thing. So it predicts the next word. If I said it's a good one. Let's try this. I've not tried this before, so I pray it doesn't embarrass me. But what's the next word? I don't know. Let's have like this. Barack. So you see that? So it knows that the next possible word after Barack is Obama. So like what it does is literally at a very high scale, what your LLMs do, what your ChatGPT does is does next word prediction, doesn't know things, it predicts things. That's why it sometimes hallucinates. And that's why we then add rags that could add context, right? So that's basically something I want to just point out about LLMs. Now, what I'll do next be, okay, I have 15 minutes left. Let's quickly get to our demo session. Let's get to our demo session ASAP. I'll try to make this fast. Collab. So I have these data sets. I have these data sets. And I'm sorry I keep using electrical examples. I studied electrical engineering, so I'm working something around this now. So that's it. So basically, we all know how transformer budget. It's not very uncommon, like we're all Nigerians here. Positive transformer is not something that's as wild. We understand how it works, right? Now, what causes transformer? I'm not spoiling. I think this is the wrong one here. What causes, like, what do you think causes it? So usually could be the voltage, the current, the power. Usually power is a function of voltage and current, power factor, temperature, light intensity, and time of the day. So I have the data set here. Everything I've highlighted like this now. That the things that affect the past faults. As the things are like 0 and 1 is what you have on that fault. Well, 0 when there's no fault, 1 when there's a fault. And everything to the left of this side affects it. Similar, the same way if I have x plus b. Good. Same way out this expression. I'm sorry, I keep using conjugation, like this expression, the values of a, b, and c is what determines x, the values of x. So in a similar sense, what I'm trying to say here is what you see under this column here, Abby, is determined by everything to the left, the time of the day, light intensity, and all that. So let's do a quick coding session. Because what I want to show you now is a simple thing. I want to show us that, you know, when I keep talking about machine learning, based on past examples, predicting for a new class, right? So let's go, guys. So imports, I'll try to really make this fast as MP imports pandas speedy. Let's run this block of code. You know what? I'm just going to, well, we live in the AI world. Import necessary libraries. How to import necessary libraries for a simple ML app. Let's use up. Okay, I think this is good enough. Do I have anything I need here? I think I can work with this. Good. So code to, I like this because although the code is pretty here, I'm just going to talk you through my thought process with the generative AI thing. So after I've got it, I've put in my library. One thing I want to do is I want to import my data as a CSV file, and Let's look this up. So good. I don't like all that. I don't need all this. Thank you, bro. But I don't need all this. Um. Okay, so let's just have this. Let me upload the data sets. The one I showed in the Excel file earlier. I'm so sorry I'm moving so fast. I think I'm not sure I use my time really well. I kind of spent a lot of time. Okay. It's not a CSV file for me. XLX file that has been uploaded. An instance of collab. Has to be collab, but let's see how it goes. Why is this guy so keen on? Okay, I don't know why this guy is so keen on this nonsense. You know what? Let's just PD. Let's have what's the code I had earlier? Okay, I like this actually. Yeah, that should be better. With the Excel file. Let's have it like this. Oh, that is the with Excel. That's how it works. Fault detection. That's XLX. Let's see. Hopefully this works. Ah, nice. It works actually. So we're able to read our data sets, and then the data we saw here, I'll be able to just have it out here. Now, one thing I want to do is split the data we gave into tests and training sets using a 80% split. I will make sure I share this code as well afterwards. Okay. So this works good. So okay. What's my label? Not label. It's called past faults. So if I want to drop past faults, is it fault or fault? Fault. And then here we have past fault. This should work. Awesome then. So then train a simple classification model with this. Okay. Okay. Do I like this? Okay, this is pretty standard. I think I can work with this. The best model and allow for predictions using the computes feature on Python. Okay. Do I like this? Let's see how this works. Okay, yeah. So now what I'll be able to do now is I'll be able to build a simple ML model. I'll be able to build a simple ML model. So now let's just pick what we're able to do is I'll be able to train the model based on these data sets. Okay, it has learned from everything in this data set. It's everything here. It has learned from here. After that learning from everything here now, we've now got to the part where now want to predict for something new, something that has not seen before. So for voltage, let's work with 220. It's asking for current. Let's work with 5 amperes. Okay, what's my cursor? Okay, my PC. Just give me a second, please. Awesome then. Give me a second, please. So I picked, let's work with 5 instead. Power should be 220 times 5. 220 times 5 would be, what would that give me again? That's about 1,000. 1 I think. 1 kilowatts. Power factors work for 7.7493. Temperature, let's work with 31 degrees Celsius. Light intensity, I think is a percentage, so let's work with 70%. Time of the day, so this works from 0 to 23.59. So let's work with 7, so it's 7 a.m. and then we see immediately it tells us prediction is at 0. Based on these things I've imputed, the fault is 0. So I did not explicitly, I didn't write any mathematical model for this. It came up with this based on past data. So I hope I've been able to explain that visually. So at this point, do you have any questions? While that was going on, I'll get resources. I'll get resources now that I can send over. But at this point, do you have any questions? I think I've come to the end of my session. Time was not exactly by our side, but I think we need to make do what we have. So do you have any questions?
Yeah, so if any of us have any question, you can just unmute ourselves, or we can just like signify by raising our hands.
I go on, did you? Can go on, please.
Yeah.
Once your mic, once you raise up, you can go on.
Unmute yourself, then talk.
Yeah, good evening.
Good evening.
Thank you so much for the section. Really appreciate. So, I'm a civil engineering student, final year. So, what brings me to machine learning is actually my final year project. It's about machine learning prediction. So, I've been having issue with data sets recently. So, I don't know if you can give me 1 or 2 tips on that.
You know what's funny?
Yes.
So I'm also studying electrical and electrical engineering here. And for my final year projects, I talked about energy profiles of building. So I'm working on something similar here, being able to cluster building similar energy profile. And when I started, I was thinking, maybe they should have meters now. I'll just go to Unilag Works to go and get the data set of all the meter readings, and I can cook with that. Turns out, Unilag does not track the electricity usage of each building. So ultimately, I had to start counting from building to building. I kid you not. Like I was counting thankfully Unilag is smaller than most federal schools, but I had to go from building to building, estimating their low usage. How many ACs do you have? How many bulbs do you have? I'm not even kidding at all. So I think the issue with data is a very Nigerian. I also have a friend that's she's also she's trying to apply. She's doing I think you guys had Ubeda come here, speaks to the community a couple of weeks back. So Josh is working on similar to what Ubeda is working on, applying AI to chemical engineering, right? And she's working with a couple of what's the word now? Enzymes, yeah, a couple of enzymes. And she's trying to get it within Nigerian context, and data sets is just extremely difficult to get here in Nigeria. Like it's very it's very, very difficult to get here in Nigeria. So first of all, I understand where you're coming from. I really, really do. Please, I think I can help you with a couple of what's the one now? Websites that can get good data from. I don't know. If it was electrical context, I would have recommended IEEE data ports. Yeah. But I know yours is more of a civil engineering thing. So
Yeah.
I could also ask a couple of my friends that do ML AI in the civil engineering space for for what's what I'm looking for how they go about it, right? And they'll just educate me, and perhaps I could reach out to you after the session at DDG, Brian.
Yes, I will. I really appreciate that. I don't know how can I contact you.
I think I can. If you work with Adidiji Ibrahim on LinkedIn, I can reach you on LinkedIn. I go by Salim Munilo everywhere.
Okay. Yes, I'm going to add you on LinkedIn. Okay. I will send you. I will follow you on LinkedIn.
No wahala, no wahala. We can speak from there. And I think another theme I want to consider is simulated data sets. So maybe not exactly, you just simulate something, like just as I don't know why, but that's a bit here and there, Sha, because if you're trying to publish your projects, that's a bit, you're using like it's not real time data. So maybe it's just a proof of concept for what you're trying to work with. I might also consider simulated data sets.
All right. Yeah. Thank you.
Thank you very much.
Yeah, thank you so much. I did you, Ibrahim. So, do you have any other person that also wants to ask 1 or 2 questions? We don't really have time. That's the reason why our session is very short today. Actually, I'm thinking maybe we should have this thing like as a version 2, like a next one. So we're going to discuss with us like are going to reach out to us when we are going to have, like, if it's possible for us to have it again. So another thing is that we also have like a physical event coming up very soon, and in fact this month on the 17th. So we are going to be having our first physical event, and we are going to be having people from different places that are going to be speaking about us. So we are going to share our graphics very soon, and so I can discuss that about us. So I'm also going to drop some messages on the group in case maybe we think maybe there's a track that we think we should bring people, because currently we are person we are bringing is going to be speaking to us on DevOps and cloud. So that aspect, I'm also going to be having someone else talking about the front end and the mobile part. So if we think like there's another aspect that we also want someone to come and speak, you can also do that as well. Yeah, so thank you so much, our speaker, for coming. I'm going to send all these resources to the group. And in case you guys don't know, our speaker here is also maybe you have seen the channel on YouTube. There's a channel called what is it called? I've forgotten. Please remind me.
Beyond the classroom.
Yeah,
Beyond the
Beyond the Class.
Classroom.
You guys can check it out on YouTube. So they talk about different people, like students like us, doing a lot of good stuff in the open source world. So you can check it out and then see they have brought a lot of amazing people. So I think this is it here. So you can just subscribe and then check out the videos. So we are going to every other thing. I'm going to send them to the group now so that we can all check them out. So thank you all for coming. It's a pleasure having you here. And if we are going to be having other thing, I'm going to let us know on the group. So thank you so much, everyone, and have a nice time.